Okay, are we all sitting comfortably? Ready to start? Good. So, welcome to this Solibri workshop, and we have a privilege to have the last presentation, so bear with us. We'll have interesting things to show you. And also I need to thank our Tekla colleagues because they didn't want to use this opportunity to we'll show our things instead. So my name is Heikki Kulusjärvi. I'm the founder and managing director of Solibri, based in Helsinki, Finland. And I have here with me, doing the actual job, Simon Gilbert from my UK office, Technical Services Director. And yesterday morning, we had Dave Jellings in his memorable speech. And he was talking about why quality assurance matters. And that's really the key issue. Today, Simon and myself will tell you what and how this is actually done, and have a live presentation. Now, this is ours, so this works. A few words about Solibri. We are focused on quality assurance, quality control, and we do that based on open BIM files. So we are not doing anything else. BIM files always. And as I said, we are headquartered in Helsinki, having offices here in UK, run by Dave Jellings. Also office in Germany, United States. Then we have partners, the black dots, they're partners, over 20 different partners in different countries. Our partners in the United States are not listed here, but there are quite a few there as well. Our customers typically are property owners, construction companies. These two groups typically have most to gain when having a good quality. Also working with architects, engineers, and also lately inspectors. Solibri is about rules, having checking rules of different kinds. And we have quite a few of them. Don't worry, I'm not going to list all of them, talk about all of them, but I will take some examples of this. For us also, it started from class detection. That was the first thing we did many years back. And we are doing a pretty good job on that. Of course, we think that's the best product in the world for doing just that. But it's only one rule that we are doing. We have quite a few others. Whether something is missing from the model, egress analysis, comparing model versions, comparing architectural structural files, do we have load-bearing walls on the same location, and so on. I'm picking up one of these. Rule number 222, component distance, as an example. And here's one use for this rule, clearance. Do we have enough clearance? And in this case, this is a picture from Japan, so obviously it's getting a little bit tight. This same rule, this is actually a template. So we can twist this rule to do several things. Clearance is one. We use the same rule for soft classes as well. Then we change parameters a little bit. Then we use that for making sure that certain objects are close by, not further than a certain distance between each others. So it's used for many purposes. So these are rule templates that our users can modify to do certain tricks. A couple of months ago, I was in Japan and meeting quite a few big construction companies out of the 10 Tenacons group, and that consists of 10 and more big construction companies. And one of the meetings, we were sort of asking, what do you like Solibri Model Checker, and what sort of rules are you using? And they were saying to me that we really enjoy using this earthquake rule of Solibri. And I had no idea what that was. I was supposed to know that. So I tried to keep a straight face, and I was sort of listening to their explanations. And they told us that they use actually this rule for that purpose. And the thing is that, well, if I simplify what they think about. You can think foundation as a cup, and then you have your columns inside that cup. But because of the earth moving, you need to have a clearance so that the concrete doesn't hit concrete. And they use this rule to check that there's enough clearance. So this same rule is also an earthquake rule. So very interesting. I'm so delighted to see and hear that these things work like that. And all these rules can be adjusted. Today, our main issue is to talk about COBie. We selected this as one of the things we do. Earlier this week, we introduced the accessibility rules that we have in Solibri Model Checker in the early. Maybe some of you saw that. Did any of you saw it? Not any of this room. Okay. But this will go through many of the basic steps that Solibri is doing, so that's good. And I guess this is a good point to give Simon the opportunity to show the real stuff. Simon, please.
Okay. I think the first sort of great starting point was a mention of the last presentation, which was to talk about the quality of the output, really. Everything we're actually basing our COBie deliverable on is related to the IFC file that we're pulling into Solibri. And actually the configuration of that IFC file is actually paramount importance, that you understand the options, the checks that you can actually carry out. Let me just pull this down a little bit. I've spent a lot of time with customers actually writing guidance notes for different software solutions. Some of them actually provide good quality export information, others provide none at all. So it's kind of, because we deal with all different pieces of software, I have to then get involved with the different authoring applications as well. So one of those is a classic, and most of the people use it in the room, which is Revit. It has an FM handover export scheme with the updated IFC exporter, and if you use it out of the box, it completely screws up your output. Okay, so please don't use it unless you know exactly what you're doing with it, because what it does, it uses a text file in the background, and the text file isn't configured by default, so you don't get any parameters. Okay, so it's kind of things that trip you up. So the key part is understanding how to get data out of the system first of all in the best possible manner. So what we're going to do is move over to Solibri now, and we're now looking at the Solibri interface. And first of all, we notice any of the Solibri model checker users in the room. Obviously, this extra tab appears when you've installed the COBie add-on. So in the Solution Center on the left-hand side here, we have made available the COBie platform and the UK resources. It has to be activated by your system administrator, and they have to purchase the licenses. The key part here is, when I say purchase the licenses, they're free for subscription users. So if you're a subscription user of Solibri Model Checker, you get the software free of charge. Okay? You can buy as many licenses, and the price is zero. But you have to put in the COBie platform, and you also have to put in the resources for it. So this is basically the engine, and these are the actual resources that drive the software. So we have UK resources and US resources that have been generated to date. Okay. And the other key sort of message to really create is the fact that the software solution that we're going to look at today was actually developed based upon a particular client's requirements. So I came to Solibri from a authoring vendor 2.5 years ago, and I'd spent about 2 years before that working with them to get their COBie output to a level which was satisfactory. And coming to Solibri, I noticed that there was certain functionality in the software, our information takeoff, which pretty much does what COBie is required to do, as in it visualizes data in the model and enables us to look at it from a tabulated form, and that's our information takeoff. So actually moving from what we've already got to creating an automatic routine which populated each of the sheets was relatively simple concept to try and get into your brain. So we're going to look at that solution that we've generated now, and I say it was generated with clients and real-life projects. So this hasn't been generated in the background. This has been driven by customer need. So first thing really is we're going to open a file up. Now, normally you would open up the IFC files. I'm just going to go straight into one of our Solibri Model Checker files. I'll just double-click on that. And because there are such variances between different vendors as far as where they should or shouldn't put the data, and there's one particular vendor which is very popular, which doesn't quite support the IFC schema correctly, which means we have to bend the rules a little bit in order to be able to get the data into the right locations, which provides problems for other software vendors creating COBie solutions. But the key factor here is that what we're not doing is we're not taking IFC files directly, pressing a button, and generating a COBie output. It's exactly what you shouldn't be doing. The key part is there's always some kind of issues with the models. There's always intelligent decisions to be made. So, for instance, one of the decisions might be that the M&E engineer develops all the spaces, okay, for the service spaces for the building. But from a facilities management point of view, the key part is where you access that component from. So if we have a load of extract components, and they're sitting within the room areas, but they're not part of the architectural model. They're part of a service space that's been generated by the M&E model. Then, that space actually continues across a number of a number of rooms across that floor. Then, actually, when we go to the COBie sheet, it doesn't tell the facilities manager which room to access that component from. So there's lots of questions that if we take the default IFC files, press the button, we'll get a very bad output as far as COBie is concerned. So we have decisions to make all the way through, right the way down to whether or not there's duplicate elements that shouldn't be there, and all of the compliance that COBie actually requires as far as naming conventions, making sure things are unique, and actually all the data exists. So it's pretty much, the process really is that we open the models up, we run the set of rules on the models, and ensure that the mapping is correct. And then we drive, once we're happy with the fixes in the model and we understand the model, then we can make an intelligent decision on what goes into the COBie spreadsheet or not. Okay, so first of all, if we look at the model itself, if we just select a component in the model, so this wall here, down the bottom here we end up with the data that's been exported from the IFC model. And then when we click through the different tabs here, you can see that we've got certain information that's attached to it. And if we go to the classification area here, you can see we've got a uniclass classification. Okay, it's the uniclass 2 because that was when I originally created the file. But you can see it's got a classification that's been applied to it. So there's data that's placed in this model which can then be used for COBie. Now what we're looking for is a consistent set of data in a relevant set of locations. Now, Solibri Model Checker gives us the ability to take the relevant pieces of information. And actually, depending on however many applications we take the data from, they may have put the data in different locations. The classifications system, and this is something to be aware of, classification inside Solibri does not mean classification as far as things like uniclass, new rules of measurement, that type of thing. Classification is a way of restructuring the data in order to be able to visualize it, use it, manipulate it, pass it into rules, that type of thing. So it's a different lens on the view of the actual model itself. Hugely powerful and gives us lots of flexibility. Now, I've just used it for one other purpose here. So the idea behind this is that for each of the fields in the COBie spreadsheet, I've created a classification. If I go down this classification and I take something, for instance, like the asset type. So the asset type should be one of two values, either movable or fixed. And if I open this up, what it does is it shows me the values that have been created. So as I click on this item here, it shows me all the components that have that value set within the different authoring systems. We also have one that says not applicable, which means they haven't bothered setting it at all. Okay? Or we've got the mapping incorrect. Okay. So if I pick on the asset type here and I go to the settings for this, we have a criteria-based sort of application here which goes and looks for data in different locations. So I've automatically set the template up in the background to work dynamically for the architectural tools for Revit and for ArchiCAD. Bentley's coming online very shortly, and so is Vectorworks. But if they conform to the default IFC locations, I have very little work to do. So both of them seem like we can get the standard definitions out for this information. So for instance, if I look down this list here and I'm looking for type asset, what this actually does, it says, if I'm looking in ArchiCAD here and I find a value, if I double click, I go to this property set to go and find it. So the guidance for ArchiCAD is that they put the data in the relevant place, and it's meant to be under COBie asset and asset type here. So it goes away and looks in that directory or that property set for that piece of information. For Revit, because they don't create property sets, you have to actually use the default property sets that are inside the software. Everything gets placed under an area called data. Now, there is a possibility of mapping that out and putting it back to the COBie asset area. The trouble with doing that is if we remap it out, then the IFC file that we export doesn't represent the model that's in a Revit format. So there's some sort of disconnect there because we're not really supporting the ability to create true property sets. But what we've done here is we've created the mapping system. So for any software, wherever they put the data, it doesn't restrict you to change that location. So the key thing is this gives us a combined list of the data for each field in the model. So if we had 10 models in here, we could specify where the data is, and it gives us this one list. Now that list provides two pieces of functionality. It provides a route to actually populating the sheets once we're happy with the data that's there, but it also gives us ability to drive the checking of that data from this location here. It also gives us the ability to say what kind of elements do we want to actually check in this list. So for a type element, we might not want to check sub-assembly elements of things like curtain walls, that type of thing. We may want to check the main element. So it gives us that flexibility. When we go over to the checking area, we can then go and pick which software was used to generate the architectural model. Now, the architectural model is the key one because it's going to generate the first load of data submissions. So your COBie drop 1s, your CIC stage 3s, basically up to 3s. And the idea really is that they'll contain the spaces and the zones and the facility information, the floor levels, that type of information. So it's kind of key that we pick the architectural software as being the major definer for the zones in the building and that type of thing. And as quite rightly, I've already set up the ArchiCAD and the Revit ones are in there. The model here is an ArchiCAD architectural model, and it's an M&E model from Revit. So I would pick ArchiCAD here from this list. And what that does in the background, it tells the software that when it runs the rules, it's looking for the data in the right kind of places. So it's already pre-configuring that in the background. Then what I can do is say, what stage am I generating the data for? So we have a complete set of rules which are based upon the design matrix. And the design matrix in COBie is a copy of the spreadsheet, basically, the output. And on every field in that spreadsheet, there is a CIC stage value. And it's when the data is expected to be populated in that field. So what we've done is we've created the rule set to represent the demand matrix. So at any point in time, if you're the data manager or a COBie coordinator, you can say, what stage am I generating the data for? So I can say I'm creating it for CIC stage 3. And I say OK to that. And if I open up the rules on the left-hand side here now, the rules drop down to level 3. So I can say here that everything that goes through this stage here, once I fix the issues in that, then I can go through to the COBie sheet to actually then start generating the data. So the idea behind it is that once we've got the rules in here, we hit the check button. The check button in Solibri then runs through the rules, evaluates them, and tells us where there's missing components, or problems with components, or data not present. So for instance, if we go to the type area here, we've got required components that should be there for the type. So the type should have a name. Okay? So if we click on this first one here, it says type should have a name, we can see down the bottom here, we've already got issues. So when I double click on it, it shows me the components in the 3D view that are missing data. In this case, they haven't got a type name. And to prove that point, if we click on one of the staircases and we look down into the information with the identification, the field here for type is blank. Okay? So the idea is that in certain software solutions, these kind of things are possible. In others, they're not. So it's kind of, we need to be aware of the kind of problems that can actually occur. If we go down to some of the other issues down this list, if we go down to components, it says components must have name. Okay, so we've checked they've got a name. Okay, that's fine. And it says the components must have a unique name. or unique identifier. So if I double click on this, the unique identifier for a component is in the component sheet, and it's column A. And because we're dumbing down a data source that we're looking at the moment down to a spreadsheet, what we're actually dealing with is the names of components. Actually, if we look at it from an intelligent model sort of perspective, every component knows that it's unique because it's got its own global unique identifier, and it has its internal identifier within the software as well. But when we put it into a spreadsheet, what we're actually doing is we're using the name for that component. The reason why we're using the name is that when we then go into the system sheet lists the name of the system, but then lists the component names, not the GUIDs or the global unique identifiers. So there's some kind of, a lot of this kind of information we're having to dumb down. The models contain a lot more intelligent information, but obviously we're dumbing it down just to a structure that could be read in by a database from a spreadsheet. So what we've got here is, on the screen here, is all these components here don't have unique identifiers. So when we go and click on one of these areas here, these walls that we see here do not have a unique identifier. So when I select it, so where it says here, the name of it, which is EW3, all of these have got the name EW3. Now in this case here, this is a problem to do with a particular vendor, where if you copy a component and you then don't go and rename the ID of it, that's the name that pops out of it. It doesn't happen with another vendor where they dynamically give it a true a single number. So they all have their problems, they all have their benefits, all these software vendors, but what it gives us the ability to do is see all these problems visually on screen. Now the great part about this is, and you heard in the last presentation again, once we've found an issue like this, we can right click on it, add a slide, and we can specify what the problem is. When we go to the Components tab then, it lists all the components, and those components go into the BCF file, if we export a BCF, and can then be dynamically passed through to the design teams to fix those issues. We then get the resultant IFC file back, and hopefully when we rerun the rules, it fixes the problems. We don't have the problems anymore. So the idea is we run through this section, making sure each of these items have been fixed. We get the new models through, push the button again, and hopefully they should all say OK, or they should have a tick next to them. Once we're happy with that, we can then move into the functionality in the software as far as using the COBie add-in. So the COBie add-in actually exists on the tab, and you can see here we're now looking at the COBie settings. So we have to load the COBie settings up. We can specify whether it's using the Uniclass 1.4 or 2, and obviously when we get the new version through, it will only be a case of adding the extra components in there. So if we just add in the COBie Uniclass here and say open, it loads up basically the template. The template at the moment is empty, so when we click on the relevant tabs here, you can see there's no data in any of this at the moment. The functionality inside Solibri gives us the ability down the bottom here. I've just added in another view called the Information Takeoff view. And this is what I was getting at, the fact that even if we haven't got a COBie add-on, each of these areas here could be configured to mimic one of the sheets. So for instance, if I go down to any of these areas here, so if I go down to, say, the type list, and you can see here, I've got pretty much what a COBie spreadsheet is. So when I click on any of the elements, it shows me the graphical representation in the screen. And so what we're actually doing is mapping these classifications here into the relevant tabs. And as long as the names tally up, what we can do then is then if we hit the calculate button here, I'm going to turn something off first of all, because we haven't configured it yet. So there's two tabs here called attribute and coordinate. Why we're actually looking at the data and generating and manipulating it and spotting errors in it, i.e. we're not exporting the full output, we don't really need to calculate them. Okay? So what we can do is actually don't fill those two areas. Now each of these other ones says here fill from information takeoff. So what we do is we assign an information takeoff to each of these which provide the information from the locations within the software. So they're coming from the classifications, and we store them in these information takeoff views. We say OK to that, and when we click on the calculate button here, say calculate anyway, because we should have gone through the results in the rules in order to calculate the data. It then has populated the sheet. So it's filled in the facility, it's filled in the floor. When we double click on any part of the model, what it does is it shows us graphically that part in the model. So you can see that every time we click on anything, it's showing us the components plus the spaces that are related to those components. So if we go to the actual Spaces tab, we can click on any of the spaces here, and it will guide, sort of cycle through where they are in the building. Now, if we select a number of them in one go, and then we then go to the Info function, we can also select a space in the model, hit the information icon here, and what it does then, it takes us directly to the line in the sheet where that component is. So it's a bidirectional link between the spreadsheet we can see at the bottom here against the model that we see in the view. So it's interactive, gives you the ability to actually look both ways, really. If we now click on things like the zones, we've now set up zones which actually will break it down to things like horizontal circulation, vertical circulation, all those types of things. And if we go to the types, we can see we've got the type lists that have been generated, the columns, the doors, and so on and so forth. Now, if we go to the component tab gives us extra information. So let's look at some of the components in here. And first of all, I'll take, say, the slabs, for instance. And I'm just going to take, so if we look at this here, if we take the slab which is on the ground floor, what it does is it shows us all of the spaces that are connected to it dynamically. It understands the relationships between these elements. If I go down to the walls here, and I go and pick, say, wall 41, for instance, you can see that if I zoom in, we've got a doorway here that's then connected to these two spaces. But if I pick the next wall down, you'll see that it actually adjoins and is adjacent to those spaces. So we're seeing a relationship between, which is inherent in the IFC file, between these relevant components. And that's displayed within the sheet here under the actual space names that it actually relates to. So we've done a lot of work to make sure that actually it gives the correct spaces for the right types of components. It's quite important. If we then move on to the System tab, what we can then see is that we can see that each of the components have a system relationship, a space relationship, but then a system basically also understands the components are related to the relevant spaces, but the system understands then which combined spaces it relates to. So in this case here, we can see that the system is showing all the spaces that system is related to and actually provides data for. So again, it's filling this information out automatically, and again down to the Assembly tab, which it's taking either layer-based components, which are structural components, which have their relevant materiality based in them, or whether they're assembly components and listing out the individual components that sit within the assembly. So this is all being done automatically for us. The key thing really is the rules in the background and making sure that we're not putting in things that are duplicated. So on one of the projects we run, we got a precast staircase with a precast concrete model, and we'd also then got a architectural model. Both had the same staircase in it. They both exported the IFC files, and if we'd have just took them and then put them into a COBie generation tool, we'd have had two staircases there. Okay, so there's some really simple things that happen with the system. Now, obviously, the other thing that needs to be really brought to the front of the project and actually analysed first of all is a clear definition in the employer's information requirements, the EIR, as far as what kind of components should actually make, so what assets should actually make part of the deliverable for COBie. So it's been very loosely defined on some of the projects I've worked on. Others have been very tight based upon the client itself. But actually, for us to get a meaningful COBie deliverable, it really has to come from how the maintenance of these components are actually going to be run in the FM systems later on. So that would define what parameters are required and what asset components should actually make part of the COBie deliverable. Now, obviously, there's multiple ways we can do this and see the information on the screen. We work in two key areas. The information takeoffs that we see that generate the data in the sheets, we can create a list of the component types that should actually be included or not included. So if we go to this icon here, which is not our COBie settings, this one here, which says Show Components, if I click on it, what it does, it gives us a view automatically of what are included and what are excluded components. So if I go to the included components, first of all, it shows us our model, and it shows us the type of components that are included within the COBie deliverable. So if I then now use some of the visualization techniques inside Solibri to show you this a little bit more, if I take this part of the building here, and I turn off the section view and turn off the spaces, what we're now looking at is a way of visualizing any element that is going to be part of the defined asset that's going to be included to be in solid, a solid view. So you can see these extracts or the emitters into the rooms, basically, the grills are in solid, whereas the actual pipe work here and the pipe fittings are actually not included at all. They're in wireframe. So if we switch that across and we say, now show me what are excluded, you can see we've got the opposite now. And it gives us a very detailed view on the project. So what we're doing here is trying to give you the best graphical view of exactly what your Kobe sheet is going to deliver. So you've got your definition, and you can then visualize exactly what's part of it. So we may find that on the project we worked on, there was some rod-in access points for the outside of the building. And now, essentially, they're not part of Kobe, but actually if they've got a maintenance factor applied to them and they're needed, then they can be included. Now, the issue with it is drainage isn't included within IFC, as in it's not wide enough of a remit to include drainage components. So if we created things like rod-in access points, what they would do is they would come across something like pipe fittings. Now, what we're looking at on screen here is these elbows are pipe fittings. And if I remove them from the list and say don't include any pipe fittings, I then lose the rod-in access points. What it gives us the ability to do in Solibri is actually take these in or out of the excluded list. So we work on a broad brush basis, first of all, and then we can then either include elements by overriding the default or exclude them. The other method of doing that would be to actually have a Boolean operation within the authoring software that actually said deliverable in Kobe or not. Now, Revit has one that says Kobe. It's just a Boolean operation. And if you check it, basically, we can use that list to derive the automatic generation of what's included and what's not. You still have to have the discussion with the client as far as what they actually require. So it gives us the ability to use the selection basket we've got inside Solibri to narrow down the kind of components that should or shouldn't be in there. And we do this process so at the moment what we've done is we've generated a sheet that's applicable up to, say, CIC stage 5, which would be ready for actually the installation of components on site. And then what we can do then is create subsets of those sheets based upon work packages. So down the bottom here of my classification area, you'll find that what we've got in here, we've got another classification we've created, which is looking at supply chain data. So this sort of hones down the number of components that relevant supply chain member would be installing on site. And once we've done that, we can do that by criteria, or we can do it by selection in the model, that type of thing. We can then create a saved selection set of it. It means that when we click on the calculate function here, we don't have to calculate the whole sheet. We can then calculate the supply and extract area only. When I say calculate, you'll now see that what we've actually got is we've got a Kobe sheet, and you'll notice the assembly is empty. You'll notice that the spaces are full with the spaces that are related to those components. But if we go to the type sheet, we've only got the types that relate to these types of components here. So it gives us an automatic system which will narrow down just the actual subset of data for those relevant bodies to fill in when they're out on site. Now, obviously, another company I work for, we've created an online portal which sucks in these areas. You assign it to the relevant supply chain teams, subcontractors, and it just gives them a simple form to fill in the rest of the data and then submit it back. And then we can push the data back into the authoring systems and regenerate the Kobe spreadsheets. So this is sort of the process that we do. It's very visual. It's very flexible. So we're not stuck when certain pieces of data don't come through correctly. So there's some classic scenarios where if I go to the settings here, we had to incorporate the ability to fix name formats. So although the IFC file generates information 90-odd% of the time correctly, there's the odd occasion where it does these really weird things. So, for instance, if we were including things like skirting boards, whatever, if there was a maintenance task against them, it might be wall sweeps, it might be crash barriers, might be any of those type of elements. They might be wall sweeps in something like Revit. Okay, wall sweeps, when they export out, strangely enough, give you the component name, which is the family and the type, but it doesn't give you the individual internal identifier that's automatically assigned to every other component. So what this gives us the ability to do is look at the name formats, and I can then create a name for. So the data comes through. So we've got the internal ID and we've got the component name, but it hasn't put them together. So in Revit it looks correct, but in IFC we've got a few little issues, and eventually those will be ironed out and they'll be fixed with the solution. But in the meantime, we still need to get a COBie output sorted out. And for those components, we can create an item here that says, okay, for which sheet are we actually fixing the name for? We can do a filter. So in Solibri, we can go and select a number of elements. So we can select just those wall sweeps of a certain name. And then we can then go into here and we can then concatenate two different fields together. So I could then say, in here, the actual format would be name, which would be the family and type, which is there already. Then I can put a colon and then add in basically here the BAT ID, which is the internal ID. And what I've now got is a functionality which will give me exactly the same as all the other components that have exported correctly via IFC. So we shouldn't have to do this, and it doesn't happen very regularly, and those kind of elements don't normally make COBie, so it's not really a problem. But every now and again we just get to these simple sort of issues. So we've given you the tools to be able to not really, what we're doing is manipulating the data here, we're not changing it in any way. And on top of that, then we then have to have the discussion as far as which attributes for the components should actually make the component sheet. So in this case here, we have the excluded components and property sets and the included property sets. So the biggest thing you actually have with generating any COBie sheet is there is a limitation to how much data Excel can actually deliver. Okay, so a good example of that is that the attribute sheet, if you think about a component and you just export all the data. So if I take a door in a certain vendor system and I say export all the property sets for it, there might be 600 property sets for, so tags for that one door. If you include that for every door in the model, okay, you're very quickly going to be adding lots of lines to your attribute sheet. Now, Excel has a limit of 1 million lines, okay, 11 million rows. Once you hit that, it will fail to create the COBie sheet. Okay, so actually giving it's a good way of making sure that you're not giving information that you shouldn't give in here and only giving the key pieces of information. So really look into what's included and what's excluded of the property sets. And some of the other things that the other systems do. So if I go to the System tab, we looked at it a moment ago. When we click on any of these items in the system, this is a good example. So if we have very long family and type names, and some of the object libraries that are available actually give lots of problems for COBie. So we can be in a situation where we've got a long family name and a long type, and then the 7-figure number if it was in a Revit format. And that would then be added in this list here. So the way that the System tab works is you end up with a name for the system and the components that fit within it. Okay, now the default template in the old template, say before version 2.4, basically meant that you could only have a name over here that was unique. Okay, once they introduced 2.4, what they said was that you could actually have the same name system, but the actual components that sit within it can't be duplicated. Okay, so a lot of the other systems, what they do is they don't create a concatenated list here. So in this list here, we've got mduct fitting 01, comma, and then we got the next fitting, and it's a concatenated list. So we're never going to look at that list from a point of view of visualizing it, kind of thing. It's going to go into a database. So we need it to be as efficient as possible and not restrict the generation of data. So what we've done is there's a limit on each field that says 32,000 characters in Excel. You can only have 32,000 characters in each cell in Excel. Okay, so what we do is we get to the point where it gets to almost the 32,000 characters, and if it was truncated on one of the components, it then starts a new line, calls it exhaust air again in this case, and then continues the list. Other solutions haven't done that, so what they do is they create basically a new name for the actual system and put one component in against it. The problem with that is as you can imagine already, if every component in COBie should be part of a system, you're very, very quickly going to hit that million line limit, row limit within Excel. So it's kind of, we've looked at this from a perspective of not only the ease of generating the data, the checking of the data to ensure that it's correct, and ensuring that what we're looking at in the sheets is absolutely correct before we export it. But we've also looked at the efficiencies of making sure we can still deliver a sheet as one sheet, as much as possible. Obviously, on huge projects, you may have to generate 1 or 2 sheets and then merge them together. The other thing we've done to ensure that people don't do stupid things like typo errors and things like that, is that for some of the fields, especially the uniclass fields, where we go to the type category here, for instance, and we open up the classification where it generates the data. Let's just wait for it to open, and there we go. What we've done is the classification in all the other examples just looks for different fields and looks there's a value there. The rules then go and check whether or not the value is correct or not. What we've done for the classification is that all the peach fields you see in this spreadsheet here at the bottom, the peach fields relate to other sheets. Okay. Now, they either relate to a previous sheet, so in which case here, if we look at let me just minimize this down a little bit so it's out of the way. So if we look at the component sheet, for instance, the component sheet basically says which space it's from. The value in here has to come from the space sheet. So it has to be a value in this column here. But actually, when we get to the category is relating to these fields here in the pick list. Now, many of the tools that we actually take the actual values from at the end when we generate the sheet will check that the values in the field actually relate to the ones in the pick list. And if it fails, it will tell you that they got the wrong value. So what we do in this case here, our classification says, look through the value in the field and find me a code that actually matches. If it matches, put the value in from the pick list. So we know that if we've got a matching code, we know that we're going to generate a true value for the classification, even if somebody types in the value incorrectly within their authoring system. As long as the code is found, it then generates the right data. Okay. So for our users, it's free. It's part of the Solution Center. Gives us the ability to federate models and then check them, check and validate the data, and make sure it's all correct. Gives us a very flexible way of mapping the data to ensure that we can get it from any location in the model. If it's in the default location, so you're using the tools, the standard Kobe add-ons, it will dynamically link that into the right location, so it's almost a push-button exercise as far as after you've done the checks. And then it's a simple process of exporting that data out to the spreadsheet. Okay, is there any questions that...
just going back to the system component names. The specification allows you to do 2 ways. You can do component per line.
Yep.
Which, from a database point of view, is a sensible thing to do. Whereas putting all this on one line was really, I think the thinking behind that was that somebody was going to put it in manually.
You can do it both ways.
Right?
Yeah.
But in hindsight, putting it in manually, when you then create a complicated name, is actually not very good anyway. So it was going to be difficult anyway. And when they first people started using the Excel spreadsheet, they were using they weren't using the Open Office XML one, which meant there was a limit of 65,000 records, which meant that when they generated data and then decided to cut and paste 2 spreadsheets together, create data or start with data.
Yeah.
And now we don't have a limit. But I think, from a generation point of view, one component per line in my view, is the right way to do it. The second thing is that the Kobe was designed for managing components that needed to be managed for clients. So, is it possible to say, for the client group, we don't want walls because the purpose the client has said it's going into the PPM system. The PPM system doesn't know what a wall is. It doesn't do anything to it. So it's perfectly possible to filter out a lot of that stuff. Because what's worrying is that people are going to spend a lot of time putting in a lot of data that the client never asked for and then expect them to pay for.
Well, that was the part of this bit that I said straight away at the start. Okay, so the start part was to have a very defined... so people, you're completely right, people say, oh, we want Kobe, yes. But it has to be defined. And actually, we have a number of ways of making sure what kind of components actually end up in those sheets. So we can configure that for a project-by-project basis, or you can then reuse it on other projects kind of thing. So it's a really simple process, that is, and that would refine what's in the sheets anyway.
And I think it's not a software
Yeah.
And so you help the client understand, what's your BPM system,
Mm-hmm.
but then, and it isn't just one on the client side. They're not just got one system. They've got a range of systems,
Mm-hmm.
and each one of those is going to have a slightly different requirement. For instance, screen bookings is going to be completely different to PPM and reactive maintenance. And people do have to begin to understand that.
Yep.
And I suppose that within hopefully the building smart, more client representation is going to happen, and more of the FM representation is going to happen. That's actually going to help.
Okay. So what you just said there, I've done within a couple of seconds. I've taken the walls out of it. It's not part of it anymore. Yes. No, there isn't. No, I agree, yeah. So.
I've also noticed on there that created by, that's not a valid email address.
No, it's not. But that's something that it's just that I put that in the field. So it's not. A,
From a generation point of view, what we've noticed with what people's code data, when they're filling it in the BIM application, they see a field called manufacturer.
yes.
They fill it.
They fill in the manufacturer, not the email. Yeah.
Out in the IFC, and then comes out
Yeah.
is the name,
Yeah.
not the actual email.
But that's an education thing of the people understanding what they need to put in the fields. So.
And then the other one is when they put the same email address against all of the product types.
Yep.
That's like, what are you doing that for?
There's,
You've ruined it.
that's the kind of consultancy we offer on the jobs that we've worked on. So it's kind of.
I mean, I saw you doing the check there to say, right, those component names are missing, this is missing, but that just does not make sense.
Mm-hmm.
You've now made it so that instead of having from the type
Yep.
to the contact,
Yeah.
we've now got the type to 20 different contacts.
Yep.
Are you checking those sort of things as well?
Consistency sort of checks like that. Yeah, I mean, we haven't got rules in there at the moment to do that, but it's one of those things that we're going to do those in the background as far as a dynamic check that does it anyway, and then shows you those results. We could program a rule to actually check that. So based upon a type name that it actually only has one contact, if you're with me. So, and we can do that within the information takeoff now, and it's not a big job to do.
Because, I mean, we're working on that, the coding into FM systems and out, what we're now dripping experiences.
Mm-hmm.
But it's absolutely critical to get that connectivity between the types,
Yeah.
contacts, and the right information going in there.
Yeah.
Because doing half the job is just not
Mm-hmm.
acceptable.
Yeah, understand.
So, there are questions?
When you say it's too big, you're talking from a model perspective point of view? You can obviously reduce the data down in the sheet to actually what you want to actually generate, and then generate multiple sheets if you wanted to. Yeah. No, and that's the route forward. So what we're doing is the spreadsheet is just an interim sort of measure, and then we'll just pump it out to XML. So there is no limit. There's no limitation on the data that goes into Solibri as far as the size of the model files. So there shouldn't be any limitation on whatever we're exporting either. So.
Can I just say, the reason why spreadsheets are used, because most FM systems
I think we all know that in time you won't be using Excel spreadsheet, you'll be using more than other space places. The main reason that the government chose the Excel spreadsheet is it was the lowest common denominator that everybody in the industry could use. That was the purpose of
putting the data in, but also for people to get the data out.
Yeah. Yeah, but I mean, that was the government thinking behind it.
David, what you're saying is, I think you're going to find that the FM industry is I think Catherine Fontana said, we actually, from our perspective, are not actually all coordinated and organised. You know, so sometimes we make assumptions about what that's like, and we got a specification from logistics organisation, and in that specification it said you will have to connect to all these different things, and we've got in-house system, but we don't know what one.
Again, I think
Okay. I think.
just one more point here, aside with the purpose or not. What we have here is a system which will respond to what the market and the government is asking for. It is configurable. If that configuration changes, then the system can change accordingly.
Yeah,
We just use market what you want.
what you're sharing is you're saying that if somebody a client came along and said, right, I want to use the client spreadsheets, one for this system, one for that system, one for that system, one for that system, one for that system, you can say,
And it's a very good discussion, and it indicates that there's a lot of knowledge in the audience about Colby, and also we can do a lot with that. Are there sort of, people may not all know of Colby, are there any kinds of other questions as well? It's clear that you can actually do quite a lot of things with Solibri Model Checker. This was very focused on Colby now, but the general quality assurance that needs to be done for many other purposes is equally important for us and for our customers. Okay.
Pub time.
Yeah, okay. So, thank you very much.
Thank you.
Thank you for staying late. I know, like you said, pub time. Miller time, that's what we call it. So anyway, thanks for being here today. I think we appreciate all the sponsors. We appreciate BRE. We appreciate UKI for having the sponsor today. And hopefully we can do something like this again, actually. It'd be kind of nice. Thank you. Have a good weekend.